Hello everyone. In this video, we want to present our group assignment of MKG 3004 Numerical Analysis, in which we are from Group 5 of Kumpulan 3, and our lecturer is Dr. Chong. Before we start our demo on the app we have designed, let us introduce our group members first. We have 5 group members, and Lai is our group leader in this assignment. Now, let us introduce the outline of our app design. First, we have 3 main categories, which are finding the roots, building polynomials, and finding approximate integrals, which users can decide what they want to use. Each part has different methods. For the part about finding the roots, we have the bisection method, Newton's method, E-Kant method, and Muller's method. For the build polynomial part, it got linear interpolation, Hermite interpolation, and natural cubic interpolation. For the last category, it got the basic quadrature rule and composite quadrature rule. And there will be 3 rules in each basic and composite rule. Let's start the demo part. In the finding roots part, the equation used is the same for the 4 method. First we look at the bisection method, and we already put the equation of the function here, then we use this function for the 4 methods. Here we have the interval or an interval b, and we got the tolerance, which also means that the epsilon, for the iteration, depends on how many iteration users want. In here we just don't want to fix it until how many iterations, so we use 1000, then click the calculate button. It will show you the table here and also the graph of the bisection method. Last here are the approximated roots, which are also called the final answer for this equation. Reminder: for the multiplication part in the function, we must use the dot and the star symbol. For the power part, you need to use this dot with the cat symbols. Next, for the Newton's method, we need to have one initial guess and tolerance, others are still maintained the same, then calculate it. Newton's method will also give the approximate solution. For the secant method, we need one more initial guess than Newton's method. Here also got the function and the approximation. For Muller's method, we need 3 initial points, also need to insert the tolerance of it with the iteration. Here is the end of the finding roots. Let's come into the second category, build polynomials. This is the example question we will use later. Next we go into the build polynomial part. We got 3 methods. First, we will see the linear interpolation. Key in the x values, with the x1, x2, x3, and y values, also the same y1, y2, y3. This is the table showing the point after clicking the calculate button. This is the polynomial we get from the data points. Next is for the Hermite polynomial interpolation. Hermite interpolation needs x and y values, also with the first and second differentiation of y values. Here is your polynomial equation created. The last method of building polynomial is natural cubic interpolation. For the cubic spline, it is always a smooth curve. These are polynomials created by using the natural cubic spline method. The last part of our assignment is the approximate part. Both 2 quadrature rules use the same question. Here is also a little tip on the Matlab function. In the last main category here, we first look at the basic quadrature rule. Key in the function first, then key in the lower limit and the upper limit. Here you can choose whether you want to visualize by using midpoint, trapezoidal, or Simpson's rules. Next, we go to the composite quadrature rule. The above part still maintains the same, but here's the new thing: number of subintervals. Suggestion for the subintervals is not too large. Also, the same can compare the 3 different rules by changing the visualize part. That's all from our group. Thank you for watching. Have a nice day.